Okay, so I wanted to return to this example that we just looked at a few moments ago and show you an alternative way to do this problem. So again, I approached it by computing the area of this region, which I could do directly, right? And then moved from there, taking off that area from the semicircle of 9 pi over 8. Okay, there is another way to do it, and I do want to show this to you because we could do it all directly with calculus. So let me just explain how you would do that. So to do this, I'm going to bring my picture back in and just kind of blow it up here. Actually, hold on. I actually want a slightly bigger version of the picture, so I've zoomed in a little bit on my picture here. And let's investigate that region just a little bit more here. And here's what I want you to notice. Again, the little football region that we're interested in. If I draw the line from 0, 0 out to my point where they intersect, which happens at pi over 4, notice that this region here, this little football shape, is actually a combination of the area for the sine function that makes up what looks to be half of it, and it turns out it is, and the area of the cosine. But it's the area for the sine graph that occurs as we go from 0 to pi over 4. And then the second part here is the area that's generated by the cosine as you come out from pi over 4 to pi over 2. So what that means is you can actually set the problem up as this. Do the area from 0 to pi over 4 of, what was it? Give me a second, my mind just stopped working. 1/2 of 3 sine theta, quantity squared, d theta. And you can go through the process of working that out. And what you should get when you do that is 9 pi over 8, or sorry, 9 pi over 16 minus 9 over 8. That'll be the area for that first piece, the little blue piece there. And then do the integral from pi over 4 to pi over 2 of 1/2 3 cosine theta, quantity squared d theta. Right? And you'll get the same thing. 9 pi over 16 minus 9/8. So that when you do put those two together, you'll get a total area of 9 pi over 8 minus 9/4. So that's just another way you could have approached the problem. I think that when you go into the work of doing these integrals, it is a bit more, especially since you have to do 2 of them and evaluate them. So that is an alternative way that you could have done the problem. It is an alternative way that you could have done the problem, but you're going to get the same answer. 9 pi over 8 minus 9/4. So I did want to show you that there isn't one hard, set, fast way that you can do it. There are other ways of approaching it. And so the key here was realizing that this first half of that piece is actually just the area that's generated there as the sine graph runs from theta 0 to pi over 4. And then the other half of that region came about from the cosine graphs as it ranged from pi over 4 to pi over 2. And then we put the two things together. So that's another way you could approach this problem. Again, I'm not going to go through all the detail, but you can verify that if you work these integrals out, this is the result that you would get.